Okay, Bismillah. Just to refresh what we have covered so far in chapter 4, we have learned about moment, about the point, where we have m equal to f times d, where you have a force, the point, and the distance is the perpendicular distance. Also, we have m equal to r cross f. Right. Also, we have learned about moment, about an axis, where m equal to f d. Similarly, so if f is like this, where this is perpendicular and this is also perpendicular, or m, just remember, vector. What's the equation? Vector u dot r cross f. Right. So if you have an axis, you have a force. So yeah, any one. So those are the things that we have covered so far. Of course, the quiz on what I've covered for chapter 4 will be, I think, next week, sometime next week, inshallah. So today we'll continue with the third one. So it is still about moments, but in a different configuration, which is moment of a couple. Right? So today we'll study about moment of a couple. Saat. Okay. Now, so in this part we will define what is a couple, and also you need to know how to compute or calculate or determine the couple, right? So, these are examples of application or situation where it is related to what we will be learning. For example, if you apply force to turn the wheel there at a different hand placement there, right? So you will notice that tendency by experience we will take the outermost part, right? Because it will require less force than if we apply near to the center, right? So how does that being computed or being calculated in statics? So that's what we are learning today. Also, this is when you are applying the force on the steering wheel, right? Would also vehicle with a power steering larger or smaller? Of course, nowadays we have power steering that will include something else, right? Those who are from mechanical, you have to learn about hydraulic system, etc. But if without power steering, it's purely mechanical. So the amount of force that you apply will exactly transfer to the wheel. So normally, what is the answer here? Older vehicle. Especially if you see like a big lorry, right? You will have larger, right? You never see a big lorry with a small racing steering, right? So there's a reason for it that is related to what we will be covering. So moment of a couple is defined as two parallel forces with the same magnitude but opposite in direction, separated by a perpendicular distance d. Okay. So there's several characteristics there. If we draw in a plane or 2D plane, so it should be, it says that it should be two forces, it should be parallel, it should be the opposite. Right? Of course, but it is parallel and it will have a distance which is perpendicular to both. Right? And the magnitude should be the same. Okay. Then that will be a couple. Right? If it's not parallel or if not opposite or if the magnitude is not the same, then that will not be a couple. Right. So by definition that is a couple. So everyone understand? Have you learned about this before? Right. So now in terms of calculation, so in terms of the scalar calculation, again the equation is yet again the same. So that's moment of so in terms of scalar, it's still m equal to f times d, and if you have two forces like this, obviously this will be the d, right? It's the perpendicular distance there, so that's straightforward. And if you have in vector calculation, m equal to r cross f, right? So if you have, so it's similar to this one, m r cross f, right? If you have two forces, so it's from where to where? What do you think? Yeah, it's from one point on the force to another point of the force, right? So it can be, so if you understand the concept before, right? This one is from the point to the force, it can be any of that, right? Here from the axis to the force, it can be any of this also, right? This one? So the same thing, so any of this is applied. But, so if you have R like this, F, which F do you should put here? Is it the on the right or on the left? Because this in vector, this will not be the same, right? One be opposite to each other. If this is positive, this will be negative, right? So which one do you think? If you take this is R, is it on the right or the left? Right, one. Right. Kenapa? Yeah, if you understand what's going on here, is you can guess, right? And of course, if you apply the cross product with your right hand rule, it should be like R and then cross F, meaning that's the one, right? If you use this one, R, then cross F, and you can just check with your hand, right? If you have these two force, will it produce clockwise or counterclockwise? Clockwise. You can imagine the rotation, right? It will be clockwise. So this is where if you R cross F, you get the clockwise, right? If you have this red R cross this F, then you will get the clockwise, right? If you take R and then this F, you'll get counterclockwise, which is wrong, right? So the force is where the destination of the R should be, right? So if you use this R, this will be the F. If you use this R, this will be the F, and the answer will be the same. Right? So from any point of the force to any point of the second force, cross with the second force. You understand? So it says here, R is any position from vector to the line of intersection of F to the line of intersection of F. Obviously F and F, so it's quite confusing. But if you understand, so just to check, everyone understand what has been explained here? Meaning if you take one R and F, it should be the second F there. Alright. The net external effect of couple is that equal to 0 and the magnitude of the net moment equal to F times D. Right. I think you should know this already, right? If you take simply like this is a couple, meaning parallel, opposite, same magnitude. Summation of force should be obviously 0, right? Yes. And regardless of whichever direction it goes, because it's opposite and parallel, and the magnitude is the same, it will always cancel each other, right? So summation of moment, then you have to calculate, right? So that's the characteristic of couple basically. The net force is always 0, and net moment you'll have some value there. right? And of course, the what's it? The value of movement will depend with the magnitude of this and the distance, right? Meaning the longer the distance, the higher the moment, right? That's all this. So this is why we actually consider this as one of the subtopic, right? Because couple is special in that way. Dia memang tak ada hasil, summation force is 0. Dan coupling lah, lagi jauh lagi coupling lah dia. So that's the characteristic of couple. Right. Right. So just to illustrate, let's okay, before going with that one. Since the moment of a couple depend only on the distance between the force, the moment of couple is free vector. It can be moved anywhere on the body and have the same external effect on the body. Do you understand? Okay. Because if you look at this thing here, right? Okay, let's see. If we have a structure like this, and this is point O, let's see. If we have a force of like 10 Newton here, let's say 5 Newton here, and then we have, let's say, 1 meter, right? For example. Now, what is the net effect of this at this point? In terms of moment, okay. Net effect in the sense of, normally we have summation of force and summation of moment, and of course summation of force here become 15. Right? What will the summation of moment about point O? Basically, you have 10 times 3. This is we take clockwise, right? 10, and then 5 plus 5 times 2, right? Now, if we have a different point, let's say this is my point A, right? What will be the summation of force will still be the same. What about summation of moment about A? 3. For distance, what is the distance? It's 0, right? So it doesn't produce any moment. And then you have this 5. Obviously, if you take count close, so you have 5 times 1. Right? And that's one thing. Another thing is, meaning if you calculate the moment about different point, the moment will be different. Right? This will be much bigger number than this one because it actually produces bigger rotation about this point, right? If you hinge it here, the rotation can be quite big because of this force. Rather than you hinge it here, then this will produce a smaller tendency of rotation, right? Because the force is close by to the point. Another phenomena is like this. If we have the same point O, and then basically we have some 1 meter, but if we switch 10 Newton here and 5 Newton here, what do we do here is actually we just shift the two force to a different position, right? So summation of force is exactly the same because we didn't change any of the force, just the position. But summation of moment about point O is what? In this case, 10 times 2 and that is 5 times 1, right? Which one is bigger? On the right here, right? Because why? Because the force is further away, right? So with the bigger distance, it will produce bigger rotation, right? And if you take about point A, you expect it to be bigger or smaller than this one? It will be bigger because the distance bigger is further distance from that point, right? Now, this is the normal characteristic of what happened in terms of the effect of the moment. So if you shift the force, if you shift it further away, just like when you want to apply any force to your hammer, etc. If you shift further away, then the moment will be bigger. That's produced, right? Now, but couple, we will see couple is a bit different in that sense, right? Yep.
So can you explain this again?
Which one?
The force more, the distance if the distance is more.
The distance is more. Okay, because here, okay, what's the value here? This is 5, right? 5 counterclockwise. This is 30, 40 clockwise, right? 40 Newton meters. This one, if you take moment about O is like, what is it? 10, 2, 5, 1, so 25, is it?
Yes.
25 clockwise. This one, moment about point A, you get 10 times 1, and then 5 times 2, right? So it becomes 20 counterclockwise, right? Okay. So just by this calculation, it confirmed that several things. One is the issue of moment about this point and moment about this point on the same structure is different. Meaning the tendency of the force to produce moment about this point and about this point or about any other point is different based on where it's relatively positioned, right? For example, if I have a force in the middle here, about this point it tends to rotate this way, right? Which is clockwise to me or counterclockwise to you, right? But about this point, it rotate a different way, right? Meaning the effect of the same force on different point is different rotation. And if we shift the force, like this pair, we just bring it down here. What we do is we change the distance from this point O and point A, right? So from point A, because the distance becomes further away from that point, then the moment will be bigger. And this one, the moment becomes smaller because the force becomes smaller to the point, right? Because from the relationship, you can appreciate that bigger distance, bigger the moment, smaller distance, smaller the moment, right? So that's generally what happens to any structure, to any force. Why this become a special subtopic is because if we have two force, let's say we have two force, still two force, but now let's say it is 10 Newton here and 10 Newton here, right? What is so special about these two force?
Same force, same force.
So it becomes
Zero.
So it becomes a couple, right? Meaning by definition, when you see, okay, we have two force, parallel, opposite, same magnitude, it becomes a couple. So when you have this couple here, if you want to calculate moment about point O, what will it be? Okay, moment about assumption of force, it will be cancel, it becomes 0, okay. Moment about O, what do you do? If you calculate clockwise, so you get 10 times 3 and then minus 10 times 2 becomes 10 clockwise. If you take moment about point A, what do you calculate? How do you calculate? If you take, let's take clockwise and positive, you get 10 times 1, right? This 10 times 1, this one doesn't have any distance, so it's 0. So you get 10 clockwise. Do you notice anything?
Same.
So the effect is the same, even though we are calculating about different point, right? You can test about here also, you get 10 also, right? So, now, what if we shift the two force down, like we did before? This is 10 Newton, this is 10 Newton, right? Did we do it just like before? We just shift the pair of the force. So how do you calculate this one? Moment about point O right now. We take out clockwise positive. 10 times 2 minus 10 times 1, 10 clockwise, right? What about here? For this one, will become, if you take clockwise as positive, this will be what? This will be positive or negative? Negative 10 times 1 and then plus 10 times 2, you get 10 clockwise, right? So do you notice the trend?
Yes.
So the net effect, because net force is of course 0 also, so the net effect is always the same for couple about any different point, or if you shift it anyway. Kalau lah couple tu gimana pun sama je dia. Dia depending tahap yang sama juga. Right. So that's why we have this subtopic, because when we see a couple, then the calculation we can simplify because the effect is always
Same.
this, regardless of what position you want. It's different than the normal forces, right? So that is why it is being called a free vector, meaning the vector is shifted anywhere, the effect is the same to the structure. Right? Okay? Are you still following? Right. So the same concept will apply if you do in 3D. Right? So it's basically the same. You can test it out. Alright. So make sure you understand also the concept and what it means, because in the exam there will also some understanding question of what happened if blah blah blah, right? So make sure you can explain in words.
Couple lagi. Distance dia bukan antara couple.
Okay. If you I've already said that, right? But if you know, okay, do you remember what is the? If you just focus on the couple just now, right? Because that now we are relative to the structure, right? You have 10 Newton. 10 Newton, what is the distance between them? 1 meter, right? So if you want to calculate the couple, how do you calculate? So this is M equal to F times D, then 1, 10, clockwise, right? Now, what I'm showing that now initially that is just to show when you do in normal calculation, the answer is always the same, and yeah, okay, I forgot about that. And it is the same as this one, meaning that if you are dealing with couple, we do just need to have the information about the force and the distance between the force. The location doesn't matter, it will not affect, etc. Right? So that's why we simply can calculate this one, regardless of whatever structure it is on. Understand? But the what I showed just now is to illustrate the origin, because this one is derived from that phenomena. Right? Originally, everything is like this. Right? So it means that if you have a structure, whatever structure that you have, and then you have a couple here, for example, then you do not need to calculate individually like this one. You can wait a minute, this is couple. The effect is just that about any point is always the same. This is a couple. So if the magnitude is the same, of course. If the magnitude is different, you cannot consider it couple. That's kufu. Right? So that is where we apply this concept. Right? Where you can just concentrate on, okay, this couple, this distance, the value is what? Right? Without having to consider all the distance. Because as we showed, any distance whatever is just going back to this value. Right? As we have shown that. So the instance of moment of couple can be added together using the same rule as adding element, right? So meaning what? Meaning just like when you do summation of moment here, right? If you have many forces, moment about point is you have to calculate m times d for each individual force, and then you get moment plus plus plus, and then you get summation, right? Similarly here, meaning if you have many couple, then this couple produces this moment, this couple produces this moment, and then you add together to get the summation. So that's basically this one. Alright, so let's go straight to the first example. Right. Now here's the thing. Sometimes in the question they can be quite straightforward, saying about moment, couple, right? Sometimes it's just a normal question where you use yourself to have to detect that, okay, we have a couple there, right? Anyway, so here we have a beam, and then the question already gives there's two couple there. So one is this F, one is the 2 kN. Find the magnitude of F so that the resultant couple moment is 1.5 kN meter clockwise. Alright, you understand the question first and foremost?
Yeah.
What does this mean? What does this statement mean? What is this? What is this value referring to? Yeah, it means if you calculate summation of moment, it will be 1.5 kilonewton meter clockwise. That's the question. So the question is F equal to what? Right? So what do you need to do?
Find the moment of
Alright, so first identify the couple. So we have basically this pair, right? In terms of magnitude, goes are F, and then what's the distance? 0.9 meter. And then we have another couple of this and this, 2 kilonewton. 2 kilonewton, what's the distance? 2.3 meter, right? So what we do is, if we do summation of moment, and because the resultant is clockwise, it says, so let's take clockwise to make it consistent there. So it will be positive or negative here? Positive, F times 0.9, right? Positive or negative here? Negative. Why? Because it's counterclockwise, right? So 2 kilonewton times 0.3 meter equal to, should be that one, 1.5 kilonewton meter, right? Is it consistent? This is kilonewton meter, right? This is meter, so it should be the same unit. Always check the unit, because sometimes if you have here, let's say in Newton, and then in the question it says in kilonewton, then you have to convert, either you convert here or convert here, right? Because the unit should be the same on both sides of the equal sign. But in this case, it's already kilonewton and meter, so it's consistent already kilonewton and meter. So from here, you can calculate what is F, right?
Yeah.
And that will be the answer, of course. So normally, if you have a question on couple, it will be quite easier normally compared to what we have done before, because we do not care about the structure, the distance. Meaning the distance that we only concern about is between the couple. Yeah. So if you have more couple, also it's just add another element, no problem. And to detect the rotation also, it should be easy, right? It's straightforward, right? Anyone have any problem to determine what's the rotation here? You should be able to imagine, right? Etc. Okay, so that's the calculation. So if you do the calculation, you will get that answer. Now, what I did here is I take clockwise as positive, and what the slide is doing is taking counterclockwise as positive. So you notice is when you take counterclockwise as positive, of course it will be the opposite, right? This one will be negative, this one will be positive, and that 1.5 kilonewton meter you have to put negative also, because that 1.5 the question give is clockwise, right? So if you take counterclockwise, so you have to make sure you. Easier way for me is just to take whatever this direction the summation is given already, right? To avoid any confusion. But anyway, the answer should be the same there. Any question on this one? Understood? Okay. Alright, let's try question where we have a 3D structure here. So we have 450 Newton. So both force are 450 also, of course, to make it a couple. And then the direction is as given. Find the couple moment in Cartesian vector notation. What does the question want? So in the end, what is the moment in a vector form, right? How do you do? What do you do? Or what do you need to do to calculate this one? Okay, do you want to use this one or this one? Scalar vector. Easiest way is vector, right? So if you want to use vector, so M equal to R cross F. So R will be what in this case? 0.4. If it's vector, it's in vector lah. I. What I? No, Okay, first, from which point to which point? Origin to B. A to B. Okay, what's the concept here?
Any point to
Any point.
Any point. It's not any point. It's any point on one force to any point on another force. Any point, because any point is not. It's only on this line to only on this line. Right? So what is the option that you have?
AB.
AB. Can you use RBA?
Yes.
Yes, also right. What's the difference? If you use RAB, then what happens? Which F should it be? FA or FB? For this one? How many of you say B? A? What was the reason of your choice? Okay, do you understand this concept?
Yeah.
Okay, if you have, let's say your level is FB, FA, F, B, right? If my R is from point A to point B, right? This is my R. Which F should it be? B. This one, right?
Yeah.
Why? But still, if you understand the cross, it meaning from R is going there, and then at the end there it goes to F, right? Similarly, here R, F, right? So if this is R, then F should be this one, right? It cannot be this one. So R cross F will get that one, right? So if you have this R, then this will be the F, right? So going back here, if RAB from R is from A to B, then F should be here, right? So if R from B to A, then F will be F. Alright, what is RAB? Value? Vector? 0.4i plus 0k, right? By looking, you should be able to tell, or if you still confused, then just get this coordinate and that coordinate and minus. You ambil yang mana? Okay, if you because the R is in here, right? Okay. So it only have I component, right? It doesn't go in X, Y, and Z. Right? But if this is the thing. If you do some exercises and you notice you tend to make certain mistakes because you have a habit of referring to coordinate or origin. So just be safe, you just get the coordinate, and minus. That way you tend to avoid mistakes. If you have that habit, right? Okay, but for FB, what is the vector of this? X component is?
450 times 4 plus
Betul ni? Chapter tu ni?
yeah,
What is the X component of FB? 0, right?
time 450.
Can you see it's 0?
Yes.
Baru nampak? Tadi tu 45 mendadak. And then X and Y? Constant ini? Positive. 450 4/5. Okay. And then Z? Negative or positive? Negative 450 3/5. Okay, yeah. Anyone still having problem to get this one? You should have enough practice from chapter 2 already, this one, right? This is already chapter 4. Make sure do not make any mistake here, as we mentioned from chapter 2. Any mistake here or here, then whatever you learn from chapter 3, chapter 4, chapter 5 will just, you fail to get full mark because of the mistake here, right? If you calculate RBA, then it will be the opposite, right? So this will be minus 0.4i plus 0j plus 0k. This one, can you tell what is, if you just look at FA, 0i. So y will be minus 450 4 over 5j, and then plus 450 3 over 5k. Right? Of course, you don't need to do both because you have to choose from the beginning. Okay, if I want to use A, B, it's going to be B, and then you just plug in, right? I, J, K. This one, 400, and then this one, 0. Okay, 360, is it? 27. Betul ke sikit? Minus. Betul kan? Very well.
Yes.
Matematik saya dah habis. Alright, and then you can solve. You know how to solve, right?
Yes.
Okay, if you just spend 1 minute to solve, I, okay?
0.
Basically 0 minus 0, right? 0, 0. Minus j, 0. No, this one is something, right? 0. So, minus 0, right? 0. And then plus k, 0 mana? Oh, tak boleh kan? 0.4. Right? So you basically will have some value in J, some value in K. Right? Meaning actually what does that mean is it means your thumb. If you can imagine the force is like that, so it will actually rotate in that way. About that plane, right? So it doesn't have that X component. If it doesn't shift here, it's only have Y and Z component because it's slanting that way. If you want to make that's just to understand what this means. Right? Any question? Of course, if you use this one RBA cross FA, it will be exactly the same answer because it only have this will become negative, positive, right? And then it will become the same. So make sure you understand that one, how to apply. I'm not going to spend much time on this one because we have already explained this one way back. Just if you still, just one thing is understanding. Another thing, if you take too much time, like if you take 2-3 minutes to get this one, it's not good enough for your exam because this one should be just, especially if you have triangle like this, it should be just 10 seconds. Okay. Because you have to spend. Of course, this one is quite easy because there's many zero here. But in the exam, sometimes you have calculation that you have to do, so the time should be there, not on the simple steps here. Yeah. To make sure you are able to fulfill solving all the questions in the exam. Okay. Of course, I'm talking because some of my remark is about getting good mark in the exam. Some student dia tak kisah, tak apa saya faham, saya nak ilmu kalau nak awalnya. But yeah, to be able to solve on your own sweet time is one thing, but in the time given in the exam, that's another thing. Okay, so your answer will be something like that, and make sure you put the unit also. In this case, it's Newton and meter, of course. Right? Any question? So is it clear how to apply? We have one example each. Of course, it's quite easy example in the sense that there's not many things. Okay. So form 1 and form 2. F1 and F2 form a couple. Bukan nostalgia. The moment of a couple is given by which one? According to this diagram here, we have F1, F2, R1 and R2. So if you want, okay. Which one? Which is the option that will be correct?
C.
Jadi betul. Now, one thing, you cannot. Can you switch the? You cannot, right? So there's only. So which one?
B.
R2 cross F1. Yeah. If you take R1, you should take F2, right?
Yes.
And if you take R2, F1. I think this question, this illustrates something that you need to be able to visualize also, right? Because R2 is, you have to be able to imagine the extension of the force, right? The force is along that line, right? Anyone have any question? Of course, C is out of the question because that F cross R is nothing, you know. Okay, this one is also if you understand the concept. If three couple act on a body, the overall result is which one? Okay. So force it should be equal to 0 always, but moment we have to calculate, right? It can be whatever based on the value. Alright, so let's now what will happen. Okay, until now for the 2D we always have the vertical and horizontal, right? Now we have some angle there. So the two couple act on the beam, so basically we have two couple. This is one couple here, and that's another couple, right? Of course here it's already given, right? There's two couple, then you will naturally see which is the two couple, right? You can see. But if no statement is given, how many of you can actually detect there's a couple here? Especially because if the position is like this, it's obvious, right? But if one is here, one is here, sometimes it's not that obvious. Like that one, right? You have to then okay. So yeah, make sure you also have some practice on that so that you can detect. So what do we need to do here? Okay, why I'm asking like that is because if you have couple like this, right? What will be the distance? How you will know the distance? It should be perpendicular, isn't it? And this is normally hard to define. To get that distance is quite difficult because you have to use a lot of trigonometry also that one, right? So the easiest way is to do what?
X and Y.
Yeah, you resolve into X and Y. Right? So for example, this will be this and this and this, right? And then you have a new couple, meaning this and this becomes a couple. This one will just cancel each other, right? Similarly here. Understand? So if you do that, alright, if you do that, we will end up with, if we still consider all the forces, right? One will have this couple here. If I draw the pair, it will be something like this. What will be the force? The value? 15 cos 30, right? This is the same, right? What's the distance? 2 meters. Of course, if you want to still consider the vertical, it will be just something like that. 15 sine 30, sine 30. This is straight away cancel, force cancel, moment, no moment, right? For that one, if I take the vertical one, so it will be something like this. What will be the value? 15. 4/5. Same here, right? 50. 4/5. The distance? 2 meter, right? And then we have also something like that, right? Yeah, basically this is 30. 3/5. 60. 3/5. Of course, let's cancel each other. The question one, what is the resultant couple? So basically what we do is simply summation of, it's not actually something is missing. It's actually resultant couple moment because we are calculating moment. So which direction you want to take? If I take clockwise, I just want to take clockwise because this is clockwise, this is clockwise, so it will be positive. So anyway, if you take counterclockwise, also okay. Just get a positive and negative answer in fact. So this one will be 15 cos 30 times the distance of 2 is positive, is cos clockwise. This one 0 plus this one 40 over 5 times 2 positive clockwise. This one plus 0. You should be able to get the answer straight away. Again, if you use counterclockwise positive, this will be negative. This will also be negative. Any question? So as you can see, for couple it's quite easy in that sense. Okay. Okay. What is this? This is actually referring to this one. Why is this for me a couple? No, right? Oh, we have time already. Okay, so in the end you'll get that one. So if you see on the slide, it's considered counterclockwise as positive, so it will become negative. Then you have to say it is clockwise. In our solution, we take clockwise as positive, then positive is already clockwise, right? Alright, so this one will bring to the next class, inshallah, on Tuesday. Before we end, just small announcement. I put on that. Alright, it's already 9:50, is it? So with that, we end the session. Inshallah, subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.